We want to take a look at solving logarithmic equations using properties of logarithms and the inverse property. We're given an equation, natural log of x plus 1 plus the natural log of x minus 1 equal to natural log of 3. First, recall that we have some properties of exponents. When we have a product, log of x times y is equal to the log of x plus the log of y. We can break one logarithm up into two pieces. We'll be using it in the opposite direction. Log of x divided by y would be log of x minus log of y. We have an exponent property. Log of x to any power would be that power, that number a, times the log of x. And of course we will need our inverse property. Any base a to the log base a of x is x. The base a and the log base a are the inverses of each other. Given our equation with these natural logs, first, we want to isolate these logarithms. We want to isolate the logs and get them on one side of the equation. We will be able to combine them afterwards. Now luckily, here we have ln of 3, so I can just subtract that natural log to the left side. I will have natural log of x plus 1 plus the natural log of x minus 1 minus the natural log of 3 is equal to 0. Natural log of 3 is a number. If you could subtract 3 to both sides, you can certainly subtract natural log of 3 from both sides. Now we have all our logarithms on one side of the equation. Next, we want to use those properties of logarithms. Using properties of logs, we're going to combine. We're going to combine these three logarithms into one expression. Once we have one expression, we'll be able to do work. So here I have first some addition. So I can write our three natural logs as one expression. From the addition, I know that would be a natural log of two products. So x plus 1 times x minus 1 being multiplied together. For the subtraction, remember, that came from division. What that tells me is I have a natural log of 3 being subtracted. That means 3 is the divisor. We have three separate logs we're combining into one. The positive ones, the ones being added, become multiplication in our logarithm. The ones being subtracted, or a negative exponent, would be in the denominator of our logarithm. So we have three logs now combined into one single logarithm. Natural log of x plus 1 times x minus 1 divided by 3 is equal to 0. Now that we have a single logarithm, we can exponentiate. And keep in mind, remember, natural log is log base e of x. So we're going to be using that base e to exponentiate. E raised to the whatever's on the left. The natural log of x plus 1 times x minus 1 over 3 will be equal to e raised to the 0. So the right-hand side of the equation becomes an exponent. The left-hand side of the equation becomes an exponent for the base e, because natural log is log base e. Now we have our e and our natural log. These are inverses. This is where we can take advantage of our inverse property. E and the natural log cancel each other out as inverses. I will be left only with the argument x plus 1 times x minus 1 over 3. On the right-hand side of the equation, we have e to the 0, but any non-zero base raised to the 0 power is 1. So we have the resulting equation, x plus 1 times x minus 1 over 3 equal to the number 1. What we want to do now is solve that resulting equation. X plus 1 times x minus 1 over 3 is equal to 1, and I'm just going to go ahead and multiply 3 to both sides of this equation. Cancels out the denominator on the left side, so we will have x plus 1 times x minus 1 equal to 3. Distributing on the left, we will get a quadratic. X squared minus 1, I notice the difference of squares, is equal to 3. This is a quadratic equation. We could solve it by setting it equal to 0, so that means I just need to subtract 3 from both sides of this equation. I will have x squared minus 4 equals 0, and this one is nicely factorable. It's a difference of squares. X minus 2 times x plus 2 would be equal to 0, and in order for something to multiply out to 0, that means either the x minus 2 is equal to 0 or the x plus 2 was equal to 0, which will give us two solutions. Adding 2 to both sides gives me the solution x equals 2 for the left equation. For the right equation, subtracting 2 from both sides yields x is equal to negative 2. We have two solutions. We need to check, are they valid? And immediately, I know I cannot use that value negative 2. Our original equation was the natural log of x plus 1 plus the natural log of x minus 1 equal to the natural log of 3. If we try to plug in a negative 2, the natural log of negative 2 plus 1 would give me the natural log of negative 1. This is undefined. So negative 1 is not a valid number. We can only take a logarithm of positive values. So I know I cannot use x equals negative 2. Could x be positive 2? We'll find out. The natural log of 2 plus 1 added to the natural log of 2 minus 1. Is this equal to the natural log of 3? Well, we will have natural log of 3 plus natural log of 1 equal to natural log of 3, and the natural log of 1 happens to be 0. And so we end up with a true statement. Natural log of 3 is indeed equal to natural log of 3, so our solution does check. We have a valid solution, and the solution must be x is equal to 2. And we could stop there.